In example 5, we have a garden that has a stone statue that needs to be moved in it. It's too heavy to lift, so Mr. and Mrs. Ecker have to push it. If Mrs. Ecker is pushing the statue with a force of 120 newtons at a 60-degree angle, that might be important, and Mr. Ecker pushes with a force of 180 newtons at a 40-degree angle from the ground, that also might be important. What is the combined force they exert? So what we're going to need to do here is we're going to have to find the resultant vector, and specifically we want the magnitude of the resultant vector. So let's draw some ground here. We'll draw ourselves a little diagram, and let's go with Mrs. Ecker, and she's at 60 degrees on 120 newtons. So we'll do something that looks like this. So that's, oops, that'll be 60 degrees, but it's going to have to be, let's see, there's your 60 degrees, and there's your 120 newtons. And then for Mr. Ecker, he's going to be at 40 degrees, so that's going to be here, and 180. So there's your 40 degrees, and there's 180 for your force. So what we'll need to do here, folks, is we're going to break this thing down into the x and y components of each vector. We'll add those x and y components together, and that'll give us our resultant vector. To do that, let's work with Mrs. Ecker's first. So if we want to go with her x and y, the x is going to be 120 times the cosine of 60. And then the y part is going to be 120 times the sine of 60 degrees. Now you can figure this out exactly if you wanted to, but in these cases, we're more than likely going to round here. And so if you actually do this problem, you're going to get 60 here, or type it in your calculator, and you're going to get about 103.9 here for the numerical value of each x and y component. Let's try Mr. Ecker's now. So Mr. Ecker's is going to be in blue here. That's going to be 180 for the magnitude times the cosine for the x of 40 degrees. And then we'll do 180 times the sine of 40 degrees. Same thing we did before, different numbers. If you type these in your calculator, you'll get about 137.9, and then you'll get 115.7. So how are we going to use these to find that resultant vector? Well, to do that, our resultant vector r is going to have an x component and a y component. And what we're going to do is we're just going to add each of the components from each of the separate vectors in red and blue. So we'll do 60 for the x and 103.9 for the y for Mrs. Ecker. And then Mr. Ecker is going to be at 137.9 for the x and 115.7. And we can actually just add those up now. So we've got this vector, the new resultant vector, at, let's see, 197.9. And then also at 219.6. Okay, so we got 219.6 if we just add those y components up. Now what we actually want to do here is find the magnitude of r. So if we find the magnitude of vector r, the x and the y components are just two legs of a right triangle. So we can take the square root of 197.9 squared plus 219.6 squared. Take a moment, of course, to pause the video when you need to, and you can type this in your calculator. And without further ado, you should get about 296 newtons for your force.